Hi, this is Dave Clark. I want to talk today about parameterized queries, and I prefer to use views and stored procedures whenever I'm writing SQL statements, but a lot of times we may not be the ones writing it. There might be developers writing something for an application, and they put SQL in the application, they have it embedded in there. Um, and they're doing things like that, and then they take user input and maybe do just select data from a database, but they're just modifying the where statement each time, and it just sends that query to a SQL Server database and runs it. You might get things like this query here. I'm working off the AdventureWorks 2008 database. Select some data from a table where some column equals a value, right? So here we're working off this employee table. And then somebody else comes along and they run the same thing, but they're looking for a different employee. So they run the same query, but it's just got one different thing in there is the argument. The filter and the where clause is different. By parameterized queries, we mean that we can run the statements, I'm running it here through SPA execute SQL, running that same select statement, but we notice this isn't a stored procedure, but we are able to put an argument in there, and we're not doing a declare, because if we declare an argument and assign it and then run something, it will treat that as one plan, and if we run it again, it will treat it as a separate plan. But then we add the argument here and we declare it as an integer, and then we assign it. Now, when we run these queries up here, SQL Server will put a plan in our procedure cache for each of these. When we run these two down here, it will put one plan in cache because it considers these to be the same because it is parameterized. So it says, well, I don't care what this value is out here. I'm concerned with this part of it, and this is all the same as this. So I consider these to be the same. Now, why do we care about that? Well, as we'll see in a moment, the amount of space that it takes up in the procedure cache is what we're concerned with. So let's just go ahead and run it first, and we're going to clear the procedure cache for the entire server. Now there is a statement, I believe it's flush proc in DB, which you can pass a database ID as an argument, and that's usually what I prefer to do, but I'm the only one on this server. I'm just going to wipe everything out. And then down here, when it's done, we're going to query from dynamic management view sys.dm exec cached plans, which will show us what plans are in cache, but I think that only shows us like a binary or hex value or something. So we're going to join over to the dm exec SQL text, pass in the plan handle, and then we can actually see the text. Now I have this filtered here to search for the text like business entity ID because I might have some other jobs or something running on here, or maybe system things running, and I don't want to clutter up what we see in the demonstration here. Okay, so let's go ahead and we'll just execute this. So we should see results for employee 1 and 2, then 1 and 2 again, and then our result is to what's in the plan cache. All right, so we have 5 things in here. Now this first one, that's just the query, this query itself running to show us what's in. Remember, display individual plans in cache. So that's this one running down here. So don't be confused by that. Now it looks like there's 4 others in here, and like, oh well, we ran 4 and there's 4 in there. But upon closer inspection, we'll see that we do have one in there for entity ID 1, entity ID 2, and then this one at the bottom here. Notice these both say that they're ad hoc plans. Now this one says it's prepared. What SQL Server did was it knew by looking at this plan, this query when it first ran, it knew that it could parameterize that. So it created an additional plan that is parameterized. So notice it's got argument @1 defined as tinyInt, and it's running the select statement where business entity ID equal @1. So these, this compiled plan here is associated with these ad hoc plans. Now this one, this is our parameterized query that we ran. So notice it doesn't look exactly like we did because we did the SPXecute SQL and we had the arguments at the end. But this is when it compiles the plan, this is how it defines it. And notice is only in here one time. So if we go over here, look at our use counts, we'll see that that one was accessed twice. So that from those two statements, that one was accessed twice. Now each of these was only run once, but then the parameterized query that SQL Server made from that plan was accessed twice. So now let's look at the size of these plans. This this is the parameterized one. It's 40,960 bytes. So that's 40K, and I believe the space is allocated in 8K chunks, you know, like for a page at a time. So that's 5 pages. So 40K, and the other one is 24K and 24K. So now we're looking at 48K versus 40K. And you say, well, that's not much difference. Because sometimes you won't even see it determine that it can parameterize it. So you won't get this extra overhead here. In this case, we did. So we can clearly see that when we parameterize 40K, when we don't parameterize 40K plus some, you know, n times 24K for the number of times that we run it. But you might think, well, you know, that's just such a small amount. But what happens when you run something 10 times, 100 times, 1,000 times, etc.? And this is just one query. So then if you have 100 queries that are each run thousands of times, you end up with so much, so many procedures, so many ad hoc procedures in your procedure plan that it just becomes a wasted space. And then and there's a formula that SQL Server uses to determine how much memory is allocated to the procedure plan, and that's based off your total memory and some other things. So let's say you've got 20 gig of memory and the procedure plan gets about 10% of that. So you're getting like 2 gig of memory. With running these things hundreds and thousands of, or hundreds of times, thousands of times each or whatever, the amount of space that you have can quickly fill up. And then what happens when a new query is run? SQL Server says, well, I don't have any room for this guy, so I got to move something out of the plan cache, compile this, and put it in there. Then somebody comes and they run something that was already run, but it got removed from the plan cache. So now SQL Server has to compile that again and put it in there and move something else out. So then it becomes a lot of swapping out of memory there, which gets pretty expensive, and the extra compiles, etc. So over here I've got a sample one where I'm actually running it 10 times. So there's, you know, the non-parameterized going 10, and then the parameterized going 10. So let's go ahead and run that. So there's all our results, and then I'll run the display from the dynamic management views, so you can see how quickly this adds up. So now we've got 10 plans in our cache plus the parameterized one that SQL Server made versus our one plan in cache. So here, still only taking up 40 bytes, run it a million times, or 40 kilobytes, run it a million times. It's still only taking up 40 kilobytes. It just updates the use counts. Okay, this ran 10 times. These, hey, they all only ran once, but they're taking up that much space. So now we're up to 240 kilobytes plus this overhead of 40, so 280 kilobytes versus the 40. So if we run that, you know, instead of 10 times, we run it 1,000 times. So that's 100 times what we already did here. So now all of a sudden, we're just eating up space that we really don't need to. One other thing I wanted to show here was, here's some queries. Believe I got these from Kimberly Tripp's blog, but I've seen similar things around, but I just mentioned her. I can't recall, but I think that's where they came from. But this will show the size and the count of the plans in cache by type. And by type, I mean, like, is it ad hoc, or is it procedure, or is it prepared? And there's some extra things on here to show you about things that were only used once. And why do we care about that? Well, because if something was used once, what do we care about it for? You know, like it's just sitting in there taking up space. And then down here, I have it broken out by the type and the count. So you can see if you've got ad hoc plans, you can see how many were run once, how many were run twice, how many were run 100 times. Something that's run, 3,000 times, maybe we want to change that into a procedure or something like that, or definitely parameterize it at least or something. So we'll go ahead and run this, and we can see we've got 12 ad hoc plans, and they were all single use, and we've got 2 prepared that were average about 10 times each. And down here, well, this doesn't add up here, these 13 plans to the 12, because this query ran after this query, and this query is considered one, so it has one more. But anyway, we can see that these are taking up, getting close to half a megabyte, and this is not even a tenth of a megabyte. And this is, keep in mind, this is one for the one that we made and one for the one that SQL Server made. So it's really half of this, so it's less than even 5/100ths, of a megabyte. So, and these numbers, you might think I'm, caring about such small amounts here, but this is on a server that we just cleared the cache and we just ran, 20 queries, and that's it. And I've looked at clients' sites where they've had, 40,000 ad hoc plans in their cache, and they're taking up 2 gig of space or 6 gig of space or whatever, and it's just taking up all that space. And like I said, that just makes for more room that SQL Server has to make room for and recompile stuff and all that. So anytime we can save in here, it's really worth it.